everybody, I hope you had a good week off and holiday. I know I did. It was my birthday on Labor Day, so that was fun for me. Today we are going to be doing plate tectonics in motion with graham crackers. You can use several different things for the crust layer and underneath it. But we are going to be using graham crackers to represent the crust and marshmallow cream to be representing the lithosphere. So it mentions I gave 3 different documents. One is the same document, it's just split up into 2 pages, and those 2 pages were separate documents. We have this one, and it said part 2, which was this sheet. These actually are the same assignment. However, you have to know a little bit about plate boundaries before you can start with this one. So we are going to start with this one. You are going to read the teacher background information. This one uses chocolate pudding as the lithosphere. Again, it's up to you what you use. You can use Cool Whip, you can use marshmallow cream, you can use pudding. I mean, you can even use sour cream if you wanted to, but then you can't eat it afterwards, or if you do, that's kind of gross. I don't know. I don't want graham crackers with sour cream. I'd rather have graham crackers with marshmallow. So we are going to start with this one. Let's learn about divergent boundaries. So a divergent boundary means that two plates are diverging apart. So divergent, diverging apart. Now what happens with this stuff in the middle right here is that is new ocean floor that is being built while these 2 plates move apart. Okay? That is divergent boundary. Divergent, diverges apart. Okay. Transform boundary. That is when it goes and slides across. Okay? Convergent boundary is when 2 plates put so much pressure on each other that they converge together. We get things like mountains. So converge together, coming together, converge. Okay. Now I'm going to read you the exact definitions. Divergent boundaries occur where 2 plates move apart, creating new ocean floor. These boundaries occur along mid-oceanic ridges, an oceanic plate, and on oceanic plates, and create rift valleys on continental plates. Examples include the Mid-Atlantic Ridge and the African Rift Valley. Transform or lateral boundaries. Those occur when 2 plates are moving past each other horizontally, creating earthquakes along fault lines. Due to the constant force of friction, and an example of that is the San Andreas Fault in California. Convergent boundaries occur where 2 plates are crashing into each other. 2 plates crashing into each other. There are 3 types of convergent boundaries. Continental, continental. So we have a continent and a continent, and they are coming together like this. Okay? We have ocean and a continent. Okay? We have ocean and ocean. I don't have another blue tray, so we're gonna pretend this tray is also ocean. Ocean and ocean. Okay. Continental, 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 oceanic, ocean, ocean. Okay. Continental, continental boundaries occur where there are two continental plates crash into each other along subduction zones. The less dense plate will slide underneath the more dense plate, creating trenches and mountain chains. So it goes up, goes trench, over. It's got to go somewhere, right? All right. So continental, continental. Two continental plates crash into each other along subduction zones. The less dense plate will slide underneath the more dense plate, creating trenches and mountain chains. An example is the Himalayas or our Rocky Mountains. All right. Oceanic and continental boundaries occur where one oceanic plate crashes into a continental plate, causing the less dense oceanic plate to subduct underneath the continental plate. See, it goes underneath. Ocean, less dense, goes underneath continental. Okay? Less dense oceanic plate to subduct underneath the continental plate, creating trenches and volcanic mountains. An example of that would be Andes and the Sahara mountain chains. Oceanic and oceanic boundaries occur where two ocean plates crash into each other, causing the less dense plate to subduct underneath the other plate, causing trenches and volcanic island arcs. Examples include Aleutian and Hawaiian island chains. So one goes under the other. One goes under the other. Okay. Earth's crust is broken into many large and small pieces called plates. They come together along plate boundaries. Tectonic movement is caused by the shifting of these plates due to great amounts of heat and pressure driven by convection currents in the magma. There are three types of boundaries that we just discussed: divergent, convergent, lateral/transform. Remember, divergent, apart. Convergent, coming together, there's three types. Transform, sliding. All right, now we are going to represent those with graham crackers. So, we are going to replicate the force and motion of Earth's plates during tectonic movement with the graham crackers. So our materials are graham crackers. Like I said, I'm using marshmallow cream and a knife for a spoon. I'm using butter knife. And you can either use wax paper or a plate. Make sure that it's big enough for you to be able to slide your graham crackers around on. We will need one graham cracker. We want to gently break that graham cracker in half and then into fourths. This one didn't go so well, so I'm trying again. Okay. All right. Split the pudding between you. Spoon out the pudding and drop it into the middle of the wax paper. Do not spread it out. Okay. So we just want to have some marshmallow cream in the middle. Okay, so I'm just going to get some of this marshmallow cream out. Stick it in the middle. We're not in class. You don't have to worry about sharing unless you're sharing with your siblings. Place 2 half pieces of graham crackers on top of the pudding. Okay, so we're going to set these other two aside. It says to set 2 pieces on top. Align them along the broken edges. It should look like one piece now. Okay. Read and follow directions for student procedures. Okay. So divergent boundary. Use 2 fingers from each hand to act as heat and pressure. While applying pressure down, move the plates apart about 10 centimeters. Ruler, remember we always start at 0 line. This says inches, which means that I need to flip my ruler around. Start at 0, okay? 10 centimeters is that far apart. It says about, we don't need to be exact, okay? While applying pressure down, move the 2 plates apart about 10 centimeters, okay? All right. Draw your observations in the box to the right on this sheet, okay? It shows you an actual diagram of what it looks like in real life next to that. Now you are going to compare your drawing to the actual picture of a divergent boundary. What are the differences? What do you see? My picture is different colored because my printer is running out of ink, but I still can see that there is a clear middle oceanic floor that has risen up, and my continental parts have drifted apart, which has given me the divergent boundary. Okay, convergent boundary. Use 2 fingers from each hand to act as heat and pressure. While applying pressure down, quickly crash the plates back together hard. Okay, ready? This is going to be messy. Applying pressure down, quickly. All right. Quickly crash the plates back together hard. Draw your observations in your box to the right, and then compare your drawing to the actual picture of a convergent boundary. I see mountains. I made mountains. If I was to push them even harder, they would just keep making more mountains. Okay. Now we're on okay, so this was convergent boundary. Now we're on transform boundary or lateral boundary. Use 2 fingers from each hand to act as heat and pressure. While applying pressure down, move the plates together while moving them back and forth very quickly. Braking is normal and models the breaking of the Earth's crust, which is an earthquake. Draw your observations in the box to the right. Compare your drawing to the actual picture of a transformed boundary. I got to reset my plates. My plates have broken. I need to use my other plates. Nah. I'm just going to dispose of the convergent and divergent boundary. It's missing chocolate. Sorry, I'm still chewing. Okay. Using our 2 new plates. Just gonna move some of this lithosphere back in. Okay. 2 fingers from each hand to act as heat and pressure. While applying pressure down, move the plates together, moving them very quickly back and forth. Okay. Our graham cracker has now witnessed some earthquakes. Draw your observations in the box to the right and compare your drawing to the actual picture of a transform boundary. Okay, so that completes this sheet. Now, I want you to test your memory with these sheets. Okay? So follow along, starting with this one, answer the questions, and continue on to the next page. Now, the trick is you cannot look back at this sheet. You have to do this whole experiment without this sheet. All right, so I am going to leave you to do that. It is using the exact same materials. It shows you what direction you are doing. So that's 2 graham crackers coming together. This one up here, 2 graham crackers sliding. And this one, 2 graham crackers moving apart. All right. Fill out these 2 sheets. Let me know if you were able to do it without looking back at your other sheet. Okay. Remember that plates slide around on the lithosphere. It's like a giant puzzle living on liquid. Okay? Almost like the viscosity of this marshmallow cream. It's kind of hard, but it's still liquid, right? But if I was to turn this over right now, nothing's going to come out. But if I was to leave it like this for a while, it would come out because it's still a fluid. All right, the lithosphere is made up of liquid rock. Liquid rock. We're pretending this is liquid rock. Still liquid though. So eventually it will fall out. All right. Don't forget to mark your participation. Remember, participation is optional, but it does help us to know that you're participating. So if you could leave a comment on this assignment or in the stream or on Slack, that would really help me out. And it makes me happy to see who's doing my videos. So let me know. All right, see you next time.